Right, yet another update. Right, today's been a fairly productive day. In the grand scheme of things, I've been working on this Gitio formula. It's not. I'm fairly happy with the shape that this is taking. Now, I'd like to do some work to reduce the amount of JSON in all of this. But on the whole, I think it's shaping up fairly well. Now, if we look at, let's see, how to do this. Right, okay. This is the file. Okay, one of the issues with Salt is revisiting revisiting the Salt master to rebuild the pillar data. So you really want to minimize the amount of computation required to construct the pillar data. You can't really eliminate pillar data entirely, but what you can do is you can eliminate as much as possible. And so the way we do that is within a formula, or within a state, but within a formula in particular, which is really just a sort of bounded state. What we do is we put as much as we can into these constructs, where we've got things like the default values according to certain grains. Now, because grains are all calculated locally on the minion, and because all of these imported YAML files are made available from they're made available from the master, but they're made available kind of in one hit, if you like. They're not computed, they're simply uploaded. The only part of this which is computed is this part, okay, where we do the we get the configuration. Now, in getting the configuration, what we're doing is we're looking at the config as supplied by, for example, the basic minion configuration, but also, most importantly, by the pillar. Okay, so this get config is essentially doing the getting the pillar data. Okay, and the rest of this, all of this stuff down to here, is really just merging all of those previously loaded YAML files, all of which have come from the master as just files. Okay, and this last line, okay, is loading the pillar data. Now, the pillar data can get fairly complicated, but we try to keep it as simple as possible by providing all of these fairly standard and well-known things that are likely to affect the state. Things like the operating system's family, its code name, its architecture. These are the things that are likely to change the way a formula behaves. So for example, being Windows is very different from being Linux. Being Arch Linux gives you different package names, for example, to FreeBSD or Debian, or so those are the core differences within a formula. So we do all of this work, okay, and then down here we've got a few things which can't be computed easily in those YAML files. And as this line here says, okay, we can't do this earlier, as some of the values, such as the base directory and the version, just as examples, are likely to be changed by the pillar data. Okay, and given that they're likely to be changed by the pillar data, okay, and we've seen, and we've seen up here that the pillar data basically is loaded last. Okay, that means that any computations we do down here are really tweaking stuff based on things that are likely to change. Okay, so for example, here we've got the path being changed. Okay, if you're Windows, then it's the base directory, and that is likely to have been changed by the Windows sort of OS grain. And we will construct it as just some bin directory. Whereas in most other cases, which is basically all of the Linux and Unix-like cases, we're going to construct this Gitea bin directory in a slightly different way. And down here, okay, what we're saying is if we are getting the source, getting the installation from an archive or a binary, then we are going to construct a URL based on certain functions, such as the URI base, the version, and the architecture, which again are all things which are likely to have been mangled up top. In particular, the version is likely to have changed. The URI base may have changed. In Gitea case, probably not, because we're getting it all from the Gitea download site. Okay, but that's the reason why we have this sort of mangling section down here. Okay, now in terms of the actual install, for the most part, I'm keeping all the decisions at the high level. Okay, so if we go back up to, let me see, there's the software install, okay, which basically says, right, if you've got any dependencies, then load those. That's what the package dependencies do. If, however, you've got to use upstream, and one rather hopes we do, but if it's in the supported upstream formats, and that might change, okay, there are several conditions under which that might change, not least of which is things like, for example, there may be an Arch package, but there may not be a Debian package, so package may not be supported on Debian operating systems, whereas the binary or the archive are supported, so you can choose between those. So we leave it up to the user to decide which upstream to use, but we say, look, there are certain upstream formats that are available and some which are not. That's what that does. That's just really just being polite and trying to help people out, rather than just failing catastrophically. Okay, and then down here we've got the archive installation. Okay, and this again is just using stuff to download the archive and expand it into the correct directory. And Gitea is a fairly simple example of how this all works. Okay, so that's the what we're writing kind of side. The other side is over here where we are actually iterating. Now, the way this works is, okay, there are two steps involved. The first one actually populates the testing directory with test data, and that's what this install formula does. Okay, so what I've done is this test script. Okay, if you source it as I am doing here with the dot, okay, it's not actually going to run anything, but what it does do is it defines this install formula function. And what this install formula function does is it basically takes everything that I'm working on the left hand side and copies it into a testing directory. And then down here, this is a Docker instance which I'm running, and the Docker instance is exactly the same Docker instance I'm using to run the tests, except in this case I'm just running the shell. Okay, and what I do here is I execute the salt call. Okay, so the install formula copies everything across. Because the testing directory is mounted as a volume, okay, that allows this thing to then run it as a salt call, but only after. This is going to be blue. Okay, only after we do a couple of symlinks. There's this symlink server to test. Okay, and symlink minion D to test. So this symlink minion D to test, what it does is it works in the same way as before. Okay, we've got this testing script, run tests, which is designed to run the tests. But if we source it, what we get is a number of functions defined, and there are two important functions: the symlink minion D to test, which basically symlinks the minion configuration directory from the host, and this SRV to test, which basically puts all of the formula in. But that only needs to be done once because it's symlinked in. Every time we do this install formula up top, that's really going to refresh this. Okay, so the salt call state show low SLS basically is just doing a half compile of the Gitea. So all I want to know is, does this Gitea formula actually create something which is basically sensible? And that's what we're doing here. Okay, so we just run this repeatedly. Okay, so this salt call is just us making sure that what we produce over here actually makes sense, okay, and actually builds into something sensible. And that's it. That's the sum total. So the archive one is more or less finished. I've got to do the binary. The package one's fairly trivial. The binary one's fairly trivial. Go check the dependencies are loading the Git dependency. After that, it's a question of working out how this thing is going to be tested. Now, it's going to be a matrix test. So the basic matrix is testing, for example, that the archive, the binary, and the package work in combination with operating system and architecture and version. And that comes down to what's available from the Gitea website. So that's one set of axes, if you like. The other axis is the architecture is going to be dictated by the Docker instance, and at the moment we've only got the one. Okay, so if we go over here and do is it item or items? I can never remember. Okay, so we've got these grains, okay, and oops, again, will be wrong. There we go. Okay, so here we can see we've got a Debian 11 OS Finger. The code name's Bullseye. Architecture is AMD 64, and the family is Debian. These are all the key things which are going to key into. If you remember from over here. But all of these things over here are all keyed into specifically. We're filtering by the OS family, the OS Finger, and you can see these are all over here. Okay, so you've got, you've got the OS Finger the OS code name, the OS architecture, the OS family. Those all determine all of the sexy things that happen in the formula. But it's fairly easy to change things like what the OS finger is, because we can just change the base of what the Docker is based on. Okay, so we can okay, so this thing here, okay, is fairly easy to change. We can change the operating system and the operating system version. We can even get the Mac in there. Windows is a bit more challenging, but the yeah, we can get the Mac. We can get most things inside these Debian containers. Sorry, inside these containers. But changing the architecture basically means we're going to need to run build X to cross compile these various containers, and that means setting up a QEMU emulator and QEMU emulator for the different architectures. So we've then got another axes, if you like, in our matrix of tests. So you've got architecture. Now there are only three that Gitea supports, 3 or 4 architectures that Gitea supports. Let's say there are 3, and then you've got half a dozen different operating systems. So that's 3 times, say, 6. That's 18 sets of tests. And then you've got the versions to test. Well, there are dozens of versions, so we'd have to limit that. Similarly with the operating system versions, we're testing against Debian 11, which is bullseye, but we could test against like 10, 9, and so on. We can very quickly get a very complex set of tests to do just to test this relatively simple formula. I mean, Gitea is not a complicated install by any stretch of the imagination, and yet we're already looking at 18 times, I don't know, let's say we do the last 5 versions. We're talking about 5, 8, 40. We're talking about 90 different test runs. Okay, then you've got the fact that we've got to test each of the states. Okay, so there's the basic install state, which does everything. You've got the configuration state, you've got the service state. So you've got 3 sets of states basically to check. So you're talking about 300 test runs if you wanted to exhaustively test this. So you can see that even for something relatively simple, this becomes quite a burden if you want to exhaustively test. And this is why when you're designing your CI/CD, in particular CI, CD is a bit further down, but the CI tests, okay, or the CI pipeline, okay, you might very well want to do these exhaustive tests, but you would save them until later in the day. So you would do most of your early tests on infrastructure that on an architecture and operating system that you knew basically was your target. But if you wanted to produce something like this, which is more generic, then later on down the road, after it's passed, if you like, the basic tests of the stuff we do, then you would do the 300 different tests in order to exhaustively test it on all of the things that you are willing to support, all of the operating systems, all of the OS versions, all of the architectures, and the various states that they're in. So yeah, and that's not counting all of the actual tests, which we'll get onto later. You've got the actual tests which you're going to do, which confirm that the state has done what you thought it should do. So yeah, it all looks simple. And this is the sort of thing that people miss out when they're presenting this stuff. Yeah. You see people go, oh yeah, we do X, Y, Z. We do all of this stuff, but when you actually look at it, oh, hang on a minute, where am I? Was after. Yeah, you know, so if you think about it, this is one relatively simple formula. Now you might have 100 different formula in your infrastructure. Okay, so we're talking about 300 tests for a simple formula. Multiply that by 100 different formula. If you're going to exhaustively test that, then you're talking about 30,000 tests to end-to-end test all of those formula. Then you've got the fact that if you've got 100 formula, the combinations that you can apply those in become ridiculous. Well, it's 100 factorial. In truth, of course, you're looking at a very limited subset of those that would actually make any sense. But it doesn't alter the fact that you're talking about thousands, potentially thousands and thousands of tests. Okay. And that's the reason why you end up with a massive upstream testing infrastructure, focusing down to a relatively small, in the grand scheme of things, production environment. And so when people bang on about how complicated their production environments are, you really ought to be looking at their upstream testing environment to decide whether or not they've got control of their system. Because although it's very easy to say, well, okay, we've got a 200 services. Yeah, I've seen this. People go, oh, we've got 200 services. You go, okay, that means you must have at least 200 sets of test suite, because services, assuming you're going for microservices, all the microservices have got to be independently deployable. That means there's no dependency between those services, particular version numbers. So you've got 200 sets of tests. Okay, if you've got dependencies, you are shit out of luck, because now you're into a combinatorial explosion. Okay, if you're saying, well, I've got 200, but they need to be very specific subsets, your testing infrastructure has now become infinitely more complicated, and you're not doing microservices. Okay, if you're doing real microservices, you've got 200 services, they're all basically independent, you can deploy them at any time. So you've got 200 services, 200 sets of tests. Okay, each service has an API with, let's be conservative, 5 different interface commands. Okay, so you're talking about testing 1,000 different demands on your system. Okay, every time you do a release of a service, you've got those 5 interfaces that you're going to exercise with however many tests. It very quickly becomes very complicated. Okay, now each individual service, of course, could demand a very small requirement in terms of your testing infrastructure. And again, that depends how you've done it. Okay, if you're psychotic and you insist on mocking everything, then you're in for a bad time. So, yeah, mocking. Okay, testing's a whole nother thing. When should you mock? When should you not mock? How much is good testing? How much is bad testing? What kind of code coverage should be aiming for? The answer to all of those questions is it depends. Okay. Right, okay, I'm fed up with this now. I didn't do any writing today. I know I said it was either this or writing, but it turns out to be this. So I'll do the writing. I did give more consideration to the documentation. Because one thing you'll notice from here is not a huge amount of documentation, and I want to get to that. Actually, just thinking about it. Okay, yeah, Docker file documentation. I really need to talk about that. This is one of the things that grits my shit about most of this stuff. There's an assumption. In fact, it's an arrogance. Okay. It's an arrogance and a naivety. Naivete. People go, oh, you just read the code and that will tell you what's going on. To which I say, that's just a bunch of bullshit. Okay, that's people who don't want to write documentation. Now, I agree that documentation which tells you what or how things are being done is largely redundant. Documentation which tells you why things are being done is essential. You just can't get away from it. And unfortunately, with all of this declarative configuration management stuff, a few lines of comment can save you a huge amount of aggravation. I mean, just explaining in a couple of lines what, for example, all of this shit does. If you look at something like, something, well, I mean, actually, all of this YAML stuff is a good case in point. Okay, you've got these dense structures. Okay, which, yeah, sure, if you know what you're looking at, they're not actually that big a problem. Yeah, you've got a file directory, you've got something which is creating a file, a directory, and you've got something which is extracting an archive, basically. Okay, but for example, this format keyword arguments is a macro. It's probably worth knowing what that does. Oops. Similarly, go away. Similarly, all of this, okay, when you look through it, sure, you know what it's doing. The question is why. Why am I installing all this shit? Why am I installing this MarkSafe here? Okay, I can tell you why. Because I happen to remember. Okay, the reason for installing this is that when you install all this stuff, okay, the MarkSafe which is installed is a higher version. It's more recent, and unfortunately, for whatever reason, they've decided to remove certain library calls from the MarkSafe install. So you have to install the older version, which includes those. Otherwise, you end up with errors being produced. Now, even now, okay, and it's only been, what, 2 or 3 days since I discovered this. Okay, even now, I'm looking at that and thinking, what was the error message? I know why I did it. It was to fix a problem. And I know the problem was something to do with the fact that one of the MarkSafe libraries, or one of the MarkSafe modules that was provided by the old MarkSafe 2.0.1 is no longer provided, was relied upon. And I can't remember what it was relied upon by. I assume PyTest Infra, but it might not be. It could be relied on by Salt. I honestly don't remember. I shall have to investigate. But the point is that if I put some fucking documentation in there, okay, I would have known why I had to do that. I mean, like I said, I know broadly why. But if I came to this in, I don't know, 2 months' time, I would look at that and go, why did I install that separately? What the hell's markup safe got to do with this? It's something to do. Oh, it was something to do with. Was it something to do with Sphinx? I think it was something to do with Sphinx. You see, and this is the problem. Okay, and this is where documentation is invaluable, and that's what I've got to do. I've got to catch up with all of that crap. I'm sorry, am I inconveniencing you? Poor Kenny. What was it? Right. Okay. Oh, here we go. Yeah, this was the problem. Okay, so they removed this soft Unicode from markup safe. Yeah, so they removed that, and it caused a problem. And I can't remember what the problem was in my particular instance. Okay, so that, you know, gives you some idea. If I go back to yeah. Come on. Having a bad day, Kenny. Yeah, well, you wriggling around is really not helping. And on that note, I'm going to stop. Yes, you're not helping. Mr. Kenny. Right. Okay. Well, it's no good staring at me like that. All right. That's it. I'm done for the night.